Alright, by now, quite a few of you have gotten bitten by the ham radio bug. And the one thing that's keeping a lot of people from getting involved in amateur radio in general is the price. People don't want to go ahead and spend $300, $400, $500, up to $600, even up to $1,000 to get into a hobby to find out in the long run that it's not going to be something that they're going to enjoy. But that doesn't mean you have to not get into it. Today we're going to get into modding FRS radios. Now a lot of the hardcore, die-hard amateur radio guys are going to piss and moan about this, but the way I see FRS or PMR radio for Europe, which are the simple two-way radios, I've showcased these on the show before. Now, they're going to piss and moan, oh, this is like the instant messenger MySpace Facebook of radio. This is where all the flamers and all, you know what, the bottom line is it's a radio. You know, if you give people the tools to become an asshole, they will be an asshole. Yeah, there are a lot of assholes on the FRS and PMR bands, but you know what? If it's just you and a couple of friends playing around with antenna designs and just different operating modes, that's great. I'd rather experiment on this rinky-dink $15 radio, rather blow out my $250 handheld. Now, these radios do operate very close to the 70 centimeter band of amateur radio, which is in the 440, 450 megahertz range. I'm not going to get too specific. These operate 460, 470, 480, depending on what region you're in, so look up the frequencies. But reason being is because PMR and FRS radios are so close to the amateur radio 70 centimeter band, I'm going to get into a bunch of antenna designs later on, which will also be applicable for FRS radio. And I'll actually show how to design the antenna dimensions for both amateur radio as well as FRS, so you guys can get started into the wireless wilderness. The first thing we're going to need is a radio with an antenna jack. Unfortunately, if you want a PMR or an FRS radio that has an antenna jack, you're going to be paying quite a bit of money for it. And as technophiles, we're not going to go and settle for that. So in this segment, we're going to go ahead and modify two different radios with two different RF jacks, much similar to what we've been doing with the Wi-Fi. But being that this is a lower frequency, it's a lot more forgiving for mistakes. So let's readjust the camera, we'll go to the table side and get started. There's going to be quite a bit of improv in this segment, so take what you've been learning from the show, from past seasons and episodes, to heart when doing this. These are the two most typical sized radios. Now this radio actually has a coil antenna, which we'll get to in a minute, and this one is quite literally just a piece of wire. Now we're going to need some kind of RF connector that'll be able to handle the 70 centimeter or 450 to 480 megahertz frequencies. Now, I have a chassis or panel mount BNC connector. I'll put a picture up, and I've got a standard polarity, not reverse polarity, SMA. Now, this is actually a really easy mod to do, especially when you have a smaller radio. We're going to put this into this one. We're going to put the BNC into the larger radio. But if you notice, both of these connectors, much like a lot of the ones that we've worked with Wi-Fi, in fact, if you weren't told, this looks exactly like the Wi-Fi ones that we've been working with in the past. They've got these little nuts and washers on them that allow us to mount it into your device. Now the one thing I like about this is actually a GPS cable. This goes from an MCX to a standard polarity or just a regular SMA jack. You can buy these things off eBay pretty cheap. It's kind of hard to find panel mount female BNC jacks, so you might actually just be stuck buying one of these cables and then sacrificing it. We'll probably just cut it about there and splice it in. This would be the easiest solution if you really wanted to do this. Like I said, they're really easy to get, and they come pre-crimped onto the coax. Now, as always, if you're using coax, you're going to have to use something rated for the frequencies that you're in. LMR 195 that we have been using for Wi-Fi is more than enough. However, it does get a little inflexible, it's kind of rigid. This is actually RG 174. Now, if you have leftover RF jacks from your Wi-Fi experiments, they will also work. Just compensate for what components you have in your area. Alright, so basic tools and plow, we're going to need a soldering iron, basic cutting and fabrication tools because we're going to have to chip away some plastic and cut some plastic away. We got the multimeter just in case the tester shorts, we got a fuse, and I got a hot glue gun here. I would really recommend epoxy putty, or even Gorilla Glue. But just for the first time's sake, so you can get used to what you're doing, hot glue can be removed easily if you make any mistakes. Once you know your design works, go on to something a little bit more permanent. And of course, you know, we've got a utility knife because we're going to have to do some cutting. Alright, I'm going to clear the table off, and I'm actually going to start on this one. This is actually a Motorola Talk About T5320 radio. This one is just a cheap-ass off-brand Maxis GRMS radio. Both of these radios only have about a 1/4 watt power output. That's pretty much standard. Some radios say they can go up to an 8-mile range, but I really wouldn't hold my breath on that. Some radios can go up to a 1/2 watt. I don't care how many features or how much you pay for a radio. The most important thing about your radio is the antenna and the power output. So these have shitty antennas, they have shitty power output. Let's get some better antennas on these so they're not as shitty. I've gone ahead and removed all of the screws from the radio, and as you notice, it just comes in half like so. Here's our antenna. The antenna mounts to this small little trace right here, this copper pad on the PCB. This is your signal. The reason I know this is because when the antenna is in place, it quite literally gets screwed down into this area like so. Now if we take a look at this antenna, it's nothing more than a coil of wire. Of course, not the most ideal thing, but later on we're going to have to replicate or modify this so we actually have an antenna on this thing. Now we need to go and find a ground point. Now the reason I decided to go with the BNC connector, let me take off this nut and washer and I'll show you why. Now we are going to need a little bit of wire and we're going to have to go and manipulate this a little bit, but not by much. If you notice that the BNC connector fits in almost as if it was designed to, but it goes down a little too far. We need this signal wire here. We can run a small amount of everyday Joe Schmo wire and connect that, and the shield needs to find another common ground point. So if we take the multimeter and we test for continuity, as always, radio circuits have a tendency of using a common ground, and we're just going to test for continuity. So let's see, negative pad, there's a negative pad there, that's not a negative pad, that's not negative, that's not negative, there's a negative. Well, if we know that this is a negative ground right there, we could probably take our shield, which has, let me see if I can get a nice good shot of it. It's got this tab right here. We can take that tab and solder it to the ground point right here. So we have our signal and ground. So we're going to fire up the iron and we're going to get that soldered in place. But as soon as you try to put the radio together, you'll notice that it's got this plastic tab right here. This is where the antenna used to go. This tab is going to get in the way. So we're going to have to use our fabrication tools. In this case, I'm just going to use a pair of wire cutters and maybe even go through with the Dremel. If I can, I'll just use the razor blade, but we got to get this post out of the way. Now what's bad about this is once we get rid of this post, we're actually doing structural damage to this. This screw holds the radio together. So we need to make sure that we don't destroy this to the point where the radio will fall apart. And we might actually have to compensate later on to make sure that there is no looseness to this, because you don't want to put too much stress on your RF point and it break off. So let me cut frame, get rid of that post, fire up the soldering iron and get to work on this. I've already gone ahead, taken a small length of the RG174 from that cable I explained earlier. Now you could use plain wire, typical 20 gauge copper wire, but I'd highly recommend trying to stick with coax. Now pre-tin the wires. Now I'm going to pre-tin the actual pads on the board. Let me make sure I'm on camera with this. Got one here. And we got one here now. I'm doing this inside the case, which is a really stupid idea because the heat will probably start melting plastic. So you got to be careful for that. Now am I on frame here? Okay. So we're going to tack the signal to the signal, much like many of our Wi-Fi cards and Bluetooth cards we've modded. And we're going to tack the shield to the shield, just like so. There we go. Now, this coax is going to have to lead into the BNC connector. And the BNC connector actually has a solder cup, which will lead in a certain amount. Now, I've trimmed this a bit long, just for this sake of you can't cut something to be longer. And this should fit inside the solder cup. Sorry if I'm getting a shitty angle on this, but it's really hard to do this on frame. Where am I on frame? There I am. Alright, so there's the solder cup. That's just being held in by gravity right now. I'm going to go ahead and feed some solder in. You've got to be careful not to use too much heat, because it's just like with the Wi-Fi mods, the dielectric material, this plastic on the center conductor, doesn't like to be very hot. Now we're going to just take this, and there's a little tab on the actual connector itself right here. I want to pre-tin that real quick. Try to bend this around so I can get it on frame. Am I on frame? Yeah, I'm a little high. There we go. Now this will be a little bit harder to tin because there's a lot more metal to it, but once you get a nice piece of solder on there, I'm just going to kind of hoax everything into place. I didn't bring any of my decent precision tools, so I'm just going to do this by hand. There we go. Now, this RF connector is soldered on. I'm just going to loop it around. And if you notice, I have this